on how it's made. Cycling shoes. Yurts. Marine plywood. And oil and encaustic paint. Cycling shoes have cleats for bolting the foot to the pedal. The cyclist is connected to the bicycle, body and sole. Bike shoes with clip-in cleats are a fairly recent innovation. The first versions appeared in France in the 1980s and were modeled after alpine ski bindings. Avid cyclists are very attached to their bicycles through special shoes that clip to the pedals. Cycling shoes transfer power from the foot to the pedal more efficiently than ordinary shoes. To start, an overhead press drives cookie-cutter shapes called dies through layers of fabric to punch out shoe parts. They use breathable nylon mesh for these upper pieces, and synthetic leather for parts like the shoe toe box. Synthetic leather is rigid, waterproof, and lightweight. It takes 18 pieces of fabric to make one cycling shoe. This assembler pieces together the upper mesh parts and stitches on synthetic leather trim. She adds a synthetic leather side with vent holes. It gives the cycling shoe structure. With one half of the cycling shoe now complete, it's ready for the other half. She joins it to the other half at the toe end, using high-density nylon thread. The next part is the heel cup. It's a piece of molded polyurethane that adds strength and form to the back of the cycling shoe. She stitches on trim and joins the heel cup to the rest of the cycling shoe. Next, using super strong Kevlar thread, she sews the toe box and tongue to the cycling shoe assembly. The configuration leaves open areas for mesh vents at the front of the shoe. The shoe upper is now complete and ready for the inner sole. It's made of high-density plastic. The employee tacks it to a foot mold using small nails. He sets it aside and places a pair of shoe uppers in hot and rounded clamps to warm them to a pliable state. He stretches each upper around a foot mold with a tacked inner sole. Then it's over to a machine that oozes epoxy, a high-strength glue that is impervious to weather extremes. The machine grips and folds the cycling shoe upper to the sole as it applies epoxy to seal them together. The epoxy hardens quickly, and a computer-controlled grinder gets rid of the excess. Now, a spinning brush applies a different epoxy, which will need heat to activate it. At the next station, a worker applies a release agent to a mold. He inserts a piece of carbon fiber, a high-tech composite material. He adds nylon for texture. He flips the upper part of the mold and the two parts come together like a waffle iron. Inside, the layers melt into one and then cool, creating a tough and lightweight outer sole. They punch out vent holes and trim the edges of the sole. They paint designs onto it and add a non-slip, clear coat. He glues tough nylon mesh over the vent holes to keep the dirt out. He tapes the cleat mount onto it. It will be more securely installed for the individual cyclist at the bike shop. And after an application of epoxy, it's into the oven. At the same time, he heats the glue-covered outer sole in another oven. The heat activates the epoxy. It's time to join the outer sole and the shoe upper. He carefully aligns them and presses them together. He then sets the shoe on a cradle, and hydraulic pushers apply pressure as the glue sets. He presses the foot form that's still inside the shoe onto a sharp post, stabilizing it to pull the shoe off. The next employee installs a cable closure device, which acts like a shoelace but doesn't become tangled. She adds a ratchet-style plastic buckle. Crafted by hand using high-tech materials, it's taken about an hour to make these cycling shoes, and now they're ready for a spin. For centuries, yurts have been home to herders on the Asian plateau. They continue to offer practicality and portability. Today, yurts used as second homes or studio spaces offer durability, comfort, and a barely detectable footprint. This is the engineered, modern version of the ancient nomadic structure. Compression and tension together form freestanding yurts that today feature all the modern conveniences, including kitchens, dining areas, and lofts. The vinyl polymer roof is gradually shaped into a cone. A worker folds the polymer, laying two edges beside each other on top of a formica board. Using a hot air welder, he melts the two edges together. A vinyl laminate valance is heat welded to the bottom perimeter of the roof, creating a watertight connection. Together, the workers pull the entire bottom perimeter of the roof through the heat welder. In the woodworking area, a worker drills a hole in a roof rafter. With a router, he cuts a notch that will eventually fit over a support cable. Workers spray an oil finish onto the tooled rafters for aesthetics and added weatherproofing. To keep the rafter from slipping off its cable, a worker screws a keeper bolt into a brass thread in the hole. He assembles the compression ring, which sits at the top of the yurt. He screws in rafter brackets made of galvanized steel. A worker uses silicone glue to attach a rubber gasket to the bottom edge of the roof's acrylic dome. The workers rest it on the compression ring, where it'll be held in place by cables and stainless steel springs. They begin preparing the yurt's lattice wall. The vertical grain pieces of Douglas fir are dipped in water-based, non-toxic penetrating oil. The pieces for the lattice wall are placed in a multiple head boring machine. In one shot, it precision drills 200 identical holes through several pieces of wood. A worker begins assembling the lattice wall. As he lines up the pieces of wood, he flexes them to test their strength. The alloy rivets he places in the holes will act as hinges. He uses a pneumatic riveting machine to assemble the wall. Its load-bearing capability, once fully assembled, is extremely high. Larger yurts will have walls with as many as 200 pieces, while smaller yurts will have closer to 100. Once riveting is complete, the worker makes sure the wall spreads properly. On site, workers spread the lattice wall. They bolt both ends of the lattice to the door jambs. A worker places the galvanized aircraft cable in the upper notch of the lattice wall. Workers attach roof rafters to the compression ring. The ring end of the rafter is attached to the brackets with a through bolt, while the wall end of the rafter attaches to the cable. The rafters are made of machine stress-rated wood, which can withstand the weight of snow. They level the compression ring. They drape a polyester insulation lining over the rafters and fasten it securely in place. They cover the insulation lining with a highly efficient reflective insulation. Using fiberglass reinforced aluminum tape, they seal the seam. The foil insulation rests between the lining underneath and the exterior roof. The workers now roll the vinyl laminate exterior wall around the sides of the yurt. The exterior wall is securely laced into grommets along the bottom edge of the roof valance. A worker standing in the compression ring hoists the acrylic dome up to the top of the roof and positions it on the compression ring frame. Yurt windows are sewn in with mosquito netting and have a clear vinyl covering. All in all, yurt living means never pulling up stakes. Marine plywood is used in the construction of docks and boats. You can't use standard plywood in such wet environments. Marine plywood isn't affected by moisture because it's made from sheets of a tropical hardwood that's naturally water-resistant and bonded with water-resistant glue. Marine plywood is typically used in boats for flooring, bulkheads, and furniture. The surface is typically a decorative type of wood veneer, such as oak, maple, teak, or mahogany. The core, however, is made of bonded layers of okume, a water-resistant species that grows in the hot and humid equatorial forest of Gabon in Africa. When the okume logs arrive at the factory, an automated chainsaw cuts half the shipment into pieces measuring the length of a finished panel of plywood, and the other half into pieces measuring the width of a finished panel. This produces logs with the grain running in one direction, as well as logs with the grain running in the opposite direction. This is critical because when they construct the plywood, they'll crisscross grain directions to add strength. Next, the logs go through a series of rotary blades, which progressively shave off the bark. The now barkless logs enter the rotary peeling machine. It works like a giant pencil sharpener, shaving off a continuous thin sheet called a ply, hence the term plywood. The ply is between 1 and 3 millimeters thick, depending on its position in the finished panel. Blades on both sides trim the ply, producing neat, straight edges. Then the machine rolls up the ply. The next machine unwinds the continuous ply and slices it into separate plies. If the log that produced this roll was one of those cut to the 2.5 meter length of a finished plywood panel, then this machine makes a cut every 1.2 meters, the width of the finished panel, and vice versa. This thickness of plywood has a 5-ply core. 3 of the plies remain dry, while 2 go through this machine, which rolls strong, water-resistant glue simultaneously on both sides. Now assembly begins. Alternating grain directions, the first ply is a dry one, the second a glued one. The bottom of it sticks to the ply underneath, the top to the dry third ply that goes over it. The next ply, the fourth, is a glued one. The bottom sticks to the ply underneath, and the top to the fifth and final ply, a dry one, above. Workers use a powerful pneumatic staple gun to attach this assembled core along the front edge, so that it doesn't come apart as it enters the press. The press holds 10 core assemblies at a time. The current thickness of a core is the sum of the plies plus glue. The press will reduce that by 10%. It applies about 12 kilograms per square centimeter of pressure, while at the same time heating the core to 120 degrees Celsius to literally cook the adhesive. The core exits the press after 7 minutes. The ply is now perfectly flat and solidly bonded. The wood veneer for the core's decorative facing is very thin, barely more than half a millimeter. To create a pattern resembling a hardwood floor, they join 2 strips at a time with a wavy thread of glue. Next, they join the 2 mated strips to 2 others, and so on, until the assembled veneers are the length and width of the plywood core. The core, meanwhile, goes through the glue machine, which coats both top and bottom with adhesive. The veneer sheet is also glued, but on one side only. Workers lay the veneer glued side up, then carefully place the core onto it. A second veneer, glued side down, goes on top. The okume core is now sandwiched between 2 decorative wood veneers. The press applies the same heat and pressure as it did to the core assembly, but just for 1 minute. The result? A finished sheet of, in this case, cherry veneered marine plywood. Marine plywood comes not just in a variety of veneer choices, but also in a range of thicknesses, typically comprised of 3 to 13 plies, always an odd number in order to have equal weight on either side of the central ply for balance. There are many types of paints at an artist's disposal, each producing a very different effect. Oil paint is opaque and rich. Encaustic paint, being wax-based, has a unique texture that the artist can shape, then reheat and reshape in countless creative ways. Oil paint comes in liquid form and stick form. With either, the artist can combine it with other products to modify the consistency. Being oil-based, the paint takes a couple of days to dry, so there's lots of time to work with it. However, once the coat is dry, it can't be reworked. Encaustic paint, by contrast, is wax-based, so the artist must melt it while applying it. Because wax cools and hardens so quickly, encaustic paint has a short working time. However, the artist can reheat it and work it some more. The main ingredient in encaustic paint is white beeswax. To that, they add carnauba wax, which comes from the leaves of the carnauba palm tree. Carnauba wax is quite fragile, which is why they strengthen it with beeswax. They melt them in a microwave oven on convection mode. Next, they add dammer resin, which comes from trees native to Southeast Asia. They grind the chunks of resin into powder in a coffee grinder, then mix it into the molten waxes. The resin will act as a solidifying agent, as well as make the paint glossy. Once the ingredients are evenly blended, they pour the mix through cheesecloth to filter out minute plant particles which the resin contained. They weigh out a quantity of synthetic pigment and add it to the wax-resin mixture. The ratio of pigment to mixture varies by color. Some have more wax and less pigment, and others vice versa. This manufacturer won't reveal any specifics about ingredient proportions. Its paint recipes are top secret. After mixing for about 15 minutes, the paint is ready. They carefully pour it into a mold. This type of mold produces sticks. The paint hardens in just a few minutes. They scrape off the excess and melt it back to liquid to cast the next batch of sticks. Then they unscrew the mold and pry it apart. Once the mold is safely opened, they gently extract the finished encaustic sticks. They wear gloves because the sticks are still a bit hot and can stain their hands. For those same reasons, they wrap the sticks, once labeled, in plastic. This manufacturer also produces handmade encaustic paint in another format, rectangular blocks. The process is identical. The mold is made of flexible rubber. The paint hardens sooner than in a metal mold because rubber dissipates heat far faster than metal does. Workers don't need to wear gloves when extracting the blocks because the paint is already cool and therefore won't stain their hands. To make oil paint sticks, they first make a large batch of oil paint out of walnut oil, pigment, a drying agent, and a bit of wax. Then they weigh out a specific quantity and add more walnut oil. Next, they add combined carnauba wax and beeswax, which are necessary to form the stick shape, however, less wax than for encaustic sticks. They blend all these ingredients for about 15 minutes, then pour the paint into a metal mold to cast sticks. Every batch of oil sticks undergoes drying tests to ensure the paint dries within 2 days after being applied to paper. Encaustic is the more durable of these two types of paints because it contains a larger percentage of beeswax, which is resistant to moisture. An encaustic painting, therefore, doesn't have to be varnished or put behind glass.